Thank you everyone for the patience. Thank you for the introduction. Now let's see about my talk. So what I will focus on today, it's basically what we managed to achieve so far with the fuzzing in the in Continental in BU-HMI, and also some thoughts about what will be the future. So the things that are worrying me and how we will be able to to secure even more our industry. So a few words about me. So I was born in Romania. I grew up in a city with one citadel and a Hollywood-like sign. So if you like CTFs, you can now try to find what was the city. I worked for 12 years in telecommunications, cloud computing and AI, and then moved to the automotive. I was at the origin a radio network engineer. And after that, I have several customer-facing roles for Chinese, French, and US customers. I moved to Germany in 2018 at Continental in BU-HMI in Babenhausen. So now a few words about the business unit that I'm in and the products that we are doing. So we are responsible for the display solutions, basically the new displays that you see in the car. So these are our products. I was just mentioning the head-up displays. We are now working also on the interior cameras, and this is also a reason why I'm more concerned about machine learning, because with the interior sensing and with all the new solutions that are coming now in the industry, we clearly need to somehow secure also the machine learning. Then our biggest business in the past, and I think still today, are the instrument clusters. The full digital clusters are growing as a business for us. We are entering now in the cockpit HPC solutions, and we are also focusing on sound solutions. So now, as a next step, what do we need to do to secure our product? And I liked very much the presentation from Sergey, where we highlighted the V model and the fact that we need also in the automotive to be a bit faster with testing and with all the solutions that we need to implement. It's clear that we need to bring the speed from the other industries, but we also need to be careful because a car needs to be on the road for 15 years. And then this brings a lot of additional topics that we need to be careful with. So the first point would be, and this is something that I really believe in, is to start with the boot ROM. So I believe you know that the boot ROM is a small piece of mask ROM or write-protected flash that is embedded into the processor chip. So this contains the very first code that is executed by the processor on power on or reset. If you have vulnerabilities inside the boot ROM, you will not be able to fix them without changing the hardware. I guess you've seen in the last years, even in the last months, several vulnerabilities that have been highlighted by researchers in, for example, even in the Apple products that are unfixable. This is one of those vulnerabilities that you can fix only by fully replacing the hardware. So that's why you need to be very careful on the software that you put in. Besides the fact that it needs to be really simple, the code that it's in, you also need to be very careful and to properly test it. So what we are currently doing with this, we are doing the secure code reviews for all the mask ROMs that are getting in production to be sure that there are no vulnerabilities inside. What we plan to do in the future, and this is something that where we are working together with Code Intelligence, is to try to do also the fast testing on the boot ROM software. Here, I think in Rakshit's presentation, we clearly saw what are the struggles with this. So the complexity that is added here is that usually the suppliers do not want to provide their source code because, and it's normal because it's intellectual property that they own, and then this is bringing some additional hurdles for us if we want to go in the direction of also testing the mask ROM. Then, what should be the next step beside the boot ROM? You would say that that's only a very small piece, and then there can be a lot of vulnerabilities everywhere. So there are several layers, of course, that are needed to ensure a working and secure product. I will not go in all the details about the TARA, the security concept, all the topics that you need to perform in order to make sure that your product is secure. I will focus now on the testing. And basically what we are usually doing in a project is we receive requirements from the OEMs, and then we need to make sure that they are implemented and that then tested. This kind of tests that we are now applying are static testing. I guess every project is using now a tool for doing such static testing. We have the functional testing to make sure that the product really does what it's supposed to do. Then we have some regression testing to make sure that we are not introducing some vulnerabilities and some bugs for the functions that were already developed. And then we are introducing the fast testing just before the penetration testing. So this is now how we see the product life cycle if you think only about the testing. Now, what we see in the requirements coming from the OEMs, and this you can see here on the presentation, most of the requirements can be tested with functional testing. Then you have some regression testing, and then at the end you have something like 5% out of the requirements that are requesting penetration testing and static and fast testing. If you look specifically to the static and fast testing, you will see that out of the hundreds and thousands of requirements that we receive from the OEMs, only 1% of them is referring to fast testing. So this is an interesting stuff, and we will see in one of the next slides what do we get from this. And what we've also seen in the project where we worked with Code Intelligence is that if we want to make the product secure, you need to ensure first that it's properly tested, but you also need to give this to the developers. And I've liked a lot what Yasmin also presented exactly in this direction, that at least this is what I understood, that the developers are not lazy, they are not stupid, just that they need some tools because their primary focus is to develop the product so that the product works. And then the next one is to also make it secure. And that's why I believe that if we give the tools directly to the developers for checking and fixing their code, then of course our lives as the guys and girls from the security domain will be much easier. And if now we look what actually we get from and what did we get from this 1% of requirements that we receive from the OEM. So if you have a look on the distribution, so now here we have only percentages. I cannot, of course, give the exact numbers of the vulnerabilities. We got something like 57% of the findings out of the fast testing. We got 24% out of the penetration testing and 19% out of the boot ROM secure code review that we performed. So as you can see, vulnerabilities were discovered and fixed in all the cases. So I couldn't say that one is better than the others. I still believe that you need to perform all these tasks. But here, I think we need to focus on the hurdles that we have in the automotive business, because as Rakshit also mentioned, we cannot do fast testing on code that is not ours. It's much more complicated. Of course, we are thinking about solutions for this, but at this moment, we cannot do this. So that's why you need to still secure code reviews, like in the case of the boot ROM, where it's really important, and even in the development case. And you still need to have one last step with penetration testing when you put all things together and you make sure that the different libraries are not causing additional vulnerabilities. So as you can see, we need all of them. I was impressed that the fast testing is bringing such a big impact from the point of view of findings. It is also interesting that here what I've put in fast testing as findings were only buffer overflow, specific buffer overflow. So no undefined behaviors, no other bugs that were discovered by the tool. So this is basically it. You get quite a lot from fast testing if you do it, and the ideal case would be to do it as fast as possible, so that, and to do it iterative. So basically, for all pull requests, you need to have this fuzzing so that you make sure that once you fix them, you will not introduce them later. Then, so now, if we speak about the software complexity a bit, so I will use here a comparison because as we were in 2020, and you see that it also hit me 2020 now. Um, I think in the last months we all read a lot about medicine and how all these vaccines are working, and it made me think a bit about software. So if you think about software, the software is also an ecosystem of hundreds of thousands of functions that are somehow living inside the microcontroller, and they're influencing the mean time between failures. So if you do good software, probably your device will live longer. If you do poor software, it will probably crash earlier. And this is somehow also being compared with the microbiome. So basically all the living things that are in our body that scientists didn't completely understand so far. And I guess we can say this also about software. None of us, I guess, fully understand how software works. And that's why in order to understand how software can evolve, we should have the means to measure the interactions between these different functions to see what combinations are most fit. And this is basically what we are doing in the products. We are always taking different parts. We are taking from Stack Overflow. We are taking from previous projects. We put them all together and we try to make them work. Now, of course, the software that is evolving from features point of view should always be to take the most secure path. And that's why I believe that fuzzing and this kind of testing can help us in this direction, to live with this increasing software complexity, to make sure that it's still secure, even if you put all the different functions together. And then you need to have in the end a project that still works. And we don't want to hire 200 security experts to review our code. Now, why I believe that we need to worry now. So we are in the phase that machine learning is coming into to the automotive industry. All the software complexity is coming in the automotive industry. We are moving from ECU specific products to cockpit to HPC products, and now there are more and more interactions between the software. And now, why worry? And this is the picture that I'm using here is coming from a public presentation done by a famous car manufacturer. Maybe you can realize which one is it based on the picture. And they were explaining how their machine learning algorithm is working, how they are implementing testing, how they are fine-tuning the algorithm, how they are introducing inaccuracies in their testing. As you can see, there is nothing about security in this presentation, in this slide that I'm showing. And it was a 1.5-hour presentation. They never spoke about security. They spoke about privacy, that they are careful with the data to be anonymized, but never a word about security. And the industry is now focused on making things work. And I think it's somehow normal now. I'm not surprised that it's like this. I think for each product, if you want to evolve, you need first to really make it work, and then to see, okay, how we protect against different attackers. But I'm still worried about what will happen in case an attacker will be able to gain somehow control of the machine learning. And what if just by sending a picture, an attacker will gain control of your car, finding a buffer overflow or something like this, and then they will be able to control everything just by one picture. I think we've seen this before in the industry. We've seen this with iPhones crashing just by sending the wrong image. Why we believe that this will not happen, and especially if we never introduce this in the testing. So now also some ideas on how do we prepare for machine learning. So the figure that I'm showing, it's also from a study that was done, I think 2 years ago, so it's not so recent. Probably you've seen already the image. What the researchers were able to do is just by putting a special glass on their face, they were able to impersonate a different person just by small variations in the images that are being shown. So you can see already how easy it is in the end, and I still believe that we need somehow to introduce this kind of testing in the industry. Maybe not now, maybe in a few years, but we need to think about this, because the additional attacks that come from the arrival to the automotive are adding even more complexity to the already stringent automotive requirements. So thinking that someone will be able to get into my car and just put a pair of glasses and then drive my car, I think it's quite important. Thinking about that someone, just by putting a picture on the road, will be able to crash my car, that's also something that worries me. And that's why I believe that the testing methods are needed for covering the different attacks that are coming from the machine learning arrival into the automotive business. So we need to integrate adversarial examples in our testing. I honestly, at this moment, I don't see another way than with fast testing. So that's why this is a question that I'm raising somehow for the community to see how we can push this through. Then data poisoning, again, online system manipulation. If someone can just gain access to your system, this is also something that can hurt us a lot. Then transfer learning attack. If you can just steal what the machine learning is doing and improve it or attack it in this case, this is quite some big stuff. Data confidentiality, again, if you get access to that and then you get access to all what is there, just imagine what the GDPR will say about this. So what can we do basically? So if we think about the increasing complexity, again, I believe the smart fuzzing might be our chance to discover and fix the mutations that could be induced by an attacker. And I think this is the question that I raised to you now. I presented how it worked in the projects that we are using, but can we do this with the smart fuzzing or an evolved smart fuzzer to introduce it for machine learning, to integrate it in the CI system again? For the adversarial example, so basically as part of the test set. And can we run it for each pull request? Can the developers then adapt and the neural networks fix the vulnerabilities find? I think this is something that I'm worried now. I don't have a solution in my head, and I'm sure that being among so smart guys and girls as I've seen before, I think we can find something like this together. So that's all from my side. I rushed it a bit to make sure that I don't overstep to the next presentation.
Well, thank you very much, Victor. That was a fascinating and scary talk. I mean, I've been worried about my car having a keyless key system, which I already am worried about. The idea of people putting up pictures and crashing neural networks in my car is horrifying. I mean, I've seen how hard it can be to convince companies to introduce fuzzing for their normal software. I dread to think explaining to people that everywhere where they use AI and machine learning, they have to do fuzzing as well. That's quite a challenge, but one we really should be looking into. That's a really excellent thought. Thank you very much. Okay, we already have some questions coming in. So from Paul, he says, earlier you mentioned that the required testing layers. I'm interested to know why formal proof, formal verification wasn't mentioned, particularly where existing tools can guarantee a wide range of software security properties, such as absence of runtime errors. So basically, he's asking, should we be looking at formal proof and formal verification more closely in the context of software testing?
We need to think that this is happening in real life products. So then you need to have tools that the developers can apply. So if we have a tool that a developer can then quickly apply, and we don't end up at the end of the project with hundreds of vulnerabilities, then yes, I'm in for all solutions to test. But we need to have tools. Otherwise, we still rely on the mind of the people. And I've seen some impressive stuff done by different experts from security companies, but this will not allow us to scale. So we need, because this is coming big in the automotive business, and we need to be able to scale. And we will only be able to scale with tools and with this kind of fuzzing solutions.
Yeah, excellent. So I have a DM question saying that, so they're also from an automotive company saying that they tried to convince people to use fuzzing but didn't get much uptake on it. Do you have any recommendations on how to convince the upper layers of a company that fuzzing is important if you are a developer who believes in fuzzing?
Yes. So what we did basically in automotive, it always works best if the OEM is requesting it. So that's then done, and there are no discussions about it. What we did in order to select code intelligence for our product, we did a hackathon in Babenhausen here in Germany, and we invited several suppliers. And then we showed it like this, that there are findings in the product. And then with these findings, you can go then to the management and say, hey, we have this amount of findings just in one day. We gave our software just for one day to different companies, and they come with these findings. After that, we managed to introduce it in one product, and now the findings are clearly increased. And then the direction is to show that you have the findings, and then also to speak about the UNECE regulation that is coming, and where you can clearly see that some of the mitigations that are being requested in the famous Annex 5, I would say, are pushing exactly in the direction of fuzzing. So you need to have a process to show that you don't have vulnerabilities in your code. How can you sign that you don't have vulnerabilities in your code if you don't properly test it?
Yeah, thank you.
I think this is the best approach.
Yeah. So there's another question coming in the open channel. So Maurice asks, when do fuzzing, so when you consider you've done enough fuzzing, do you go for full coverage or time-boxed fuzzing? Are there aspects you focus on when you're using time-boxed fuzzing?
So we go for time-boxed fuzzing, of course. We don't have unlimited time, so then we focus on that. And I believe that's why it's important to introduce it in the CI chain, because if you put it in the CI chain, then you can always fuzz your small increments and your small changes. You do it once, big for all the product, if you have all the source code, of course. And then whenever you push a change, you do as much as possible complete on that change. And like this, you are sure that you are not introducing new vulnerabilities.
Yeah. Okay, there's another question coming in over here. Could you please comment on the role of customer security testing requirements and development team derived requirements and the techniques for security testing? So how do how do customer and development team requirements play together?
Okay, so for this one, I believe that here you need to know very well your product. If you know your product and you know what are the issues, because no ECU is perfect, no software is perfect. All of them have their small flaws. And then with the Tara approach, you map the requirements that you get from the OEM with the issues that your ECU will probably have. And then with this, for sure, you will need to derive some additional requirements. And this will go again to the development, and they will need also to make sure that those are being implemented. Now, if you, so this is one point, and then for actual requirements that are coming from the software, then you need to make sure that they are tested. Otherwise, for sure, they will introduce some issues there.
Okay, so there are more questions coming in. I'm afraid we won't have time for all of them. So I have one last question for you. kind of an outlook question. Where do you see the future of fuzzing within Continental?
So what we target now, so it's first to have these solutions in all the products. So we need some sort of fuzzing in all the products to make sure that we fix the big chunk of vulnerabilities. Then we also need to make sure that we are still testing the protocol. So that's not something that we can give up. We need to make sure that the protocols are being properly tested. But honestly, I don't see how we can deliver products where we can sign that they don't have vulnerabilities without proper fuzzing testing.
Okay, excellent. So thank you so much for the talk. And again, apologies for the technical difficulties we had.
My apologies. I don't know what happened.
It was not your fault. That definitely was click meeting and not you.